All right, guys, so this week we're going to start to go over a few different exponent rules. So these are rules that you can use as you work through your math assignments this week, that you can refer back to these videos as I show you how to simplify, how to expand, how to solve some problems working with exponents. So the first exponent rule that we're going to talk about today is called the power of a power rule. So the power of a power rule is exactly what it sounds like. We're going to take a power and we're going to put it to another power. For example, if we had a problem that looked like this, x to the third to the fourth, how could we solve this? So we already know that we're using x here because it's a variable. We know as we move forward and when we start to look at evaluating these expressions, you might have any number in there for x. So in this case, we're still going to use x in our example. So the first thing that we're going to do when we're working with a power of a power is we're going to look at this in what's called expanded form. So when we work in expanded form, we're just going to take this expression, we're going to expand it out. We're going to write it fully expanded. So the first thing that we're going to do is we're going to look at just this x to the third. So we're going to look at just x to the third. How can we write x to the third? Expanded. Well, we know if that said, for example, 2 to the third, we know we would write 2 times 2 times 2. So when we have a number that says x to the third, we're going to expand that as x times x times x. This is our first step. We're going to take what's in the parentheses, we're going to expand that out. Now we're looking at our second step, which is our new step here. When we look at a power to a power, this entire x to the third is now being raised to the fourth power. So we know that when we're raising something to a power, we're multiplying it by itself that many times. The same goes for this problem here. We are going to take this x to the third, and we're going to multiply it by itself 4 times. Now we want to make sure that we're keeping this in expanded form. So we're going to take x to the third, and we're going to multiply it by itself now 4 times. So we've got 1, 2, 3, 4. So we've essentially got our first x to the third to the fourth. We've now got that x to the third to the fourth power. When you count up all of these x's, you can see that there are now 12. When we want to simplify this problem at the end, we can write this as just x to the 12th power, because we know that this is x times itself 12 times. So this is now x to the 12th. Let me show you another example. If we had x squared to the third, again, we want to expand this first, starting with what's in the parentheses. So we know x squared is just x times x. And we know that we're putting this to the third power, so we're going to write this 3 times. When we have x squared to the third power, we see that is going to be x times itself 6 times, or x to the 6th. Now, what some of us might already be noticing here is when we look at our powers here. When we had x to the third to the fourth, we ended up with x to the 12th. What do we notice? 3 times 4 is going to give us that x to the 12th. What do we notice here? X squared to the third. 2 times 3 is going to give us that x to the 6th. Now, I want to stress to you the importance of being able to put these in expanded form. As you work this week, you're going to be required to put these in expanded form. So this step right here of expanding your x is critical. So for each problem, you're going to make sure that you're writing out the expanded form and showing me that you understand when we do x to the third to the fourth, we realize what that looks like in expanded form. All right, guys, the next exponent rule that we're going to talk about is the product of a power. So we know when we talk about the product of something, we know that we're talking about multiplying. So in this case, we're going to be looking at what we do when we multiply different variables that have different powers. So if we were given a problem that looked something like this, x to the m power times x to the n power. How could we solve this? So essentially what this means here is we're just looking at m and n as 2 different numbers. So you have x being multiplied by 2 different numbers. Let's take a look. First thing that you're going to do is write these as an expanded form. So let me give you another example problem here. If we've got x squared times y squared times x times y to the third. So this is what we're looking at. This is an example of a product of a power. So when we look at the product of a power, first thing we're going to do is expand each one of these sections. So we know when we expand each term, x squared is going to be x times x, y squared is going to be y times y, x to no power is just x to the first power, which is just x, and y to the third is going to be y times y times y. So we know that this is the case because we pulled right from our exponents. We know that our x squared here is 2x's. We know that our x to the first power here is our 1x here. Then we also know that we have y. So we have y squared, shown right here, and we have y to the third, shown right here. So after we've expanded these, we want to come back and put this into a simplified answer. So when we're taking a look here, we want to group all of our x's together and all of our y's together. So let's start with our x's. You can see here that we have 1, 2, 3 x's, or we have x times x times x. So x to the third. Then you can also see that we've got 1, 2, 3, 4, 5 y's, or y to the fifth. So our entire expanded form here can come down to x to the third times y to the fifth. All right, guys, now we're going to talk about the power of a product rule. Power of a product rule. So again, we know that we're talking about exponents, and we know that we're working with multiplication because we see that word product. So let's take a look. When we're looking at the power of a product, we're looking at something that's going to look like this. Say we've got two numbers inside parentheses to the mth power. We can then expand that to be a to the m power times b to the m power. Now, a mistake that many of us might make going forward is to not expand this m to both variables or numbers inside the parentheses. So as we work today, let's keep that in mind to make sure that we're expanding that m to both parts that are inside the parentheses. Let me give you an example. Let's say we have 3x to the third inside of our parentheses squared. Now, the first thing that we want to do is we want to, again, expand. So we always are going to start by writing this in expanded form. So when we write this into our expanded form, again, just as we did in the earlier videos, we're going to start with just what's inside the parentheses first. So we're going to take this 3x to the third and we're going to expand it. So when we write 3x to the third, it's going to look like this. We've got a 3 times an x times x times x. 3x to the third. We just expanded what was inside of our parentheses. Let's not forget that we now have this squared. So just like we did in our earlier videos, since it's squared, we're going to multiply it by itself just one more time. So we are now multiplying this by itself twice. So we've got 3x to the third times 3x to the third. Now, as we go forward from here, we can write what's called simplified exponent form. So when we're working with simplified exponent form, we're doing exactly what it says. We're simplifying those exponents. So let's take a look. Just like we combined the x's and the y's in the last video, we're going to be able to combine terms that are the same. So in this case, you might notice that 3 and 3 are like terms, and that all of our x's are considered to be like terms. So we can combine these exponents into a simplified form. So when we work here, we can take our 3, and we know that we have our 3 2 times. So 3 times 3 is 3 squared. And we know that we have our x 6 times. So we've got 3 squared and x to the 6th. Now, we know that 3 squared is equal to 9. So we can even go ahead and simplify this further into 9 x to the 6th. We cannot simplify that x to the 6th any further because at this point we don't know what x is. If we were given a value for x, then yes, we could evaluate this expression. But our final answer here is going to be 9x to the 6th. So we took that squared power, we distributed it to the 3 and to the x to the third, to each term inside those parentheses. All right, everybody, we've made it to the last video dealing with our exponent rules, and this one is we are going to talk about what's called the quotient of powers. So when we work with the quotient, we're working with division. So we know that we're going to have something being divided by something else. So for example, if we have a problem that says x to the 5th over x to the 3rd, how can we go about solving this? Now, you've noticed in the last 3 videos, the first thing that we've done every single time is we've expanded these exponents. This one is no different. We are going to expand both the top and the bottom. So let's take a look. We've got x to the 5th. We know that that is x times x times x times x times x. On the bottom, we have x to the 3rd. Now I want you guys to notice something here. Take a look at where I'm going to write my x's. Notice how I'm lining them up directly with what's on top. Some of you are more organized than others. That won't be a problem. For some of my more artistic math students, you guys are going to want to make sure that you are lining them up nice and neat. Use the lines on your paper for this. This could be an area where instead of working on the iPad, you do write these down on paper. And I'm going to show you guys right now why that's important. We know that when we have a number over itself, so let's say instead of x over x, let's say it was 4 over 4, or 75 over 75, or 5 million over 5 million. We know that that creates what's called a giant 1. So our giant 1s are actually going to come back here when we work with the quotient of our powers. So we can create a giant 1 here, and here, and here. So this is turning into now a much more simple problem, because when we simplify out this 1 and 1 and 1, we end up with on the top here just x squared, and on the bottom we technically have a 1. Now we know that any number divided by 1 is just going to be itself, and it's the same thing here. X squared divided by 1 is just x squared. So now let's take this a step further and let's look at another example here where we're actually using numbers. So for example, if I wanted to do 4 to the 6th over 4 to the 3rd. Again, follow the same steps every single time. So our same first step here is just going to be to write this in expanded form. So you'll see here I'm writing out 4 to the 6th. And then I'm writing out 4 to the 3rd. And notice how I'm lined up here, right? This is easy for me to see. It's easy for me to understand. It's easy for me to block out my giant 1s. So in this problem now, you can see that on the top here, once these are gone, we are left with 4 to the 3rd over 1, which we know is just 4 to the 3rd. Now, this problem is different than the previous problem. In the previous problem, we were using a variable. We were using an x. In this problem, we have a number. We have 4 to the 3rd. We are able to further simplify this. When we do 4 times 4 times 4, we're going to end up with 64 as our answer. So in this case, we have a fully simplified answer, as opposed to up here when we had an x squared. This we were left with what's called simplified exponent square form. So we were left with simplified exponent form up here, and down here on the bottom we were able to fully simplify, which means we're left with just one answer.